So last week I talked about how this week we're spending basically all 5 days on a pretty big skill. So we're doing like today and tomorrow we're actually doing the skill. And then Wednesday, Thursday, we're going to be looking at how we apply the skill, like what it can be used for, and get ourselves ready to do that. And on Thursday is really when we start doing that. And then Friday probably will be like extra practice, sort of taking things up, that kind of thing. And so here we go. Just starting it out now. And it's dividing polynomials. So first of all, some sort of definitions. We don't always use f at x. Different questions might have a different thing there, g at x or who knows, right? But for us today, it's going to be f at x. So this is the function that we're going to start with. And then d at x, we're going to call the divisor. So the questions are going to be f at x divided by d at x. How do we do that? That's what we're looking at today. Okay. Q is the quotient, so that's the result of dividing. If you think about it, you probably know that word. It's a word that only comes up here and there, and sometimes we forget a little bit, but the word quotient is like if you divide two things, the result is the quotient, right? 10 divided by 2, so the quotient is 5, because 10 divided by 2 is 5. And then R at x we're going to call the remainder. So this is something that back in like grade 3, grade 4, when you started, probably grade 4, maybe even a little bit grade 5, and you start doing division and long division in particular, and you get these remainders before you start to think about decimals in your answer. That was a long time ago, thinking about the remainder of dividing, but we're going to have that again in grade 12. And people often people like to make fun of things we do in math, like they're not important. Why do we ever learn this? But why do we ever learn long division? Well, you know, it's an algorithm. I mean, for some people, they like doing it. I've actually seen students in high school forget their calculator and doing long division on tests, which is kind of crazy. But then also, if you make it to MHF, then the long division that you learned back in grade 4, grade 5, basically the same long division we're going to be doing now. So you have a bit of a head start because you've seen it before. Okay. So what this means is, let's see. We can write this division statement. This is not, I'm having a real problem with the screen here, but we'll see what happens. Division see? Statement. Okay. Goes like this. F at x equals d at x. This will make even more sense, I think, when we have done a couple of examples. If it doesn't make sense now. It might make sense now as well to some of you. Q at x plus, oh boy, R at x. So we're going to summarize, and you'll see in the instructions in practice today that it'll say to write your answers like this. So we're always going to summarize it like this. That helps us build some context in what we're doing, so we're not just following steps blindly and pushing numbers around the page without really understanding what it is. And it'll help us later on, when we start using it as well, have a really solid base of like what it is we're doing and what the result is that we're doing. It's the kind of thing that it's a very straightforward algorithm. So you can easily get very good at it, and I'm sure most of you will, which is awesome. Right? We talked about this, how this unit is a little bit more accessible from trig. It's a bit more straightforward. Step 1, step 2, step 3, you're done. But we want to have some understanding of what we're doing as well, so that when we have to apply it, we don't like it. It's not intuitive when you've done it. Okay, I did all the steps. Now what? Like, what does it all mean? That part's not necessarily intuitive. So writing the division statement can help with that. Before we move on, I want to think about this. What if I say f at x is 12? Holy cow, I didn't even pick green and it just changed on itself. That's crazy. D at x equals 5. What does this mean? It means we're going to do 12 divided by 5. We're going to do it the old long division way. Just watch. I don't know that you have to write this down. You can write it down after if you want. Oh, now I'm doing orange. 5 bracket. Remember how we do this? Divide. Oh, jeez. That's not going to work. I might have to switch over to paper here. Okay, 5 divided by 12. Look at this. I got all this stuff going on. This is wacky. All right. How do we do it? So 5 goes into 1. It doesn't, so we bump over. 5 goes into 12 twice. 2 times 5 is 10. Whoa. Okay. Then what do we do? Does anybody remember? Not at all, eh? Subtract. 12 divided by 10 is 2. Does 5 go into 2? It doesn't. So it turns out we're done. So that means 12. Oh boy. That means 12. This will be an adventure today. Equals 5. 5 times 2 plus 2. There's my divisor. 12 was the dividend. There's my quotient. There's my remainder. I'm going to do an even more, I'm going to try at least, to do an even more interesting example here, where I'm going to divide, I'm going to divide 5 again. Holy cow. Into 122. 5 goes into 12. 2 times. 2 times 5 is 10. 12 divided by 10 is 2. Here's the trick. I bring down the 2. Do you remember doing that? Vaguely, at least. How many times does 5, how many even times does 5 go into 22? 4 times. 4 times 5 is 20. 22 minus 20 is 2. But think about this. Okay, you might not know 24. You can figure it out. 5 goes into 122 24 times. Sure, I buy that. Would the remainder be 2? Like, wrap your head around that. Think about it. What does division mean? What does the remainder of dividing mean? What number does 5 go evenly into? That's close to 122. Have I lost everybody? 120, right? 5 goes into 120. You have 2 left over, 120. Like, doesn't that make sense? I hope that makes sense. That should make sense. I think it might help, even though when we start doing it with polynomials, I think it might help that you sort of think about it in this context of what exactly it is we're doing. So what does this mean? It means 5 times 24 is 120, plus an extra 2 gets us to 122. So 5 times 24 plus 2 is 122. There's your division statement. Does that make sense? If it doesn't make sense, I would encourage you to go back and think about that, especially if after we start doing this, you start getting yourself a little bit confused. So we have 2 methods of doing this, and I will make a prediction. One of them you're going to like better than the others. But you have to know both. And we're going to learn one today, and we're going to learn one tomorrow. Okay? Today, the one we're learning is called long division. I'm scared to touch the screen, so I should maybe zoom in so you can see that better, but I'm going to mess something up. Divide each polynomial by the given divisor using long division. So it gives us f at x, and then it gives us d at x. And remember, we're dividing d at x into f at x. It's f at x divided by d at x. Is just the rule that we're going with today for the lesson. That's not like always a rule, right? Okay, so let's set this up. Leave yourself a bit of space on top because you're right on the top line, so skip a couple of steps if you're on line paper. And we're going to do this, x plus 3 into x cubed plus 4x squared plus 6x plus 5, like that. There's a couple of little tricks that you can do along the way to wrap your head around exactly how this works. Because for some people, this clicks immediately. And for some people, they don't fully see what it is that we're doing here. So ask if you feel like you're stuck and you're not sure why the things work out the way they work. And I'll keep explaining it to you. But really think about the little tips. Like you can even write them down for yourself. Make your own little note when I say it, or go back and watch the video if the video works. I don't know, it might not work given that all the technology problems, but go back and look or ask, okay, and we'll go back over it. So here's what we do. We start with just the x out of the x plus 3, just that first term, the highest degree term. And we do x in, how many times does x go into x cubed? In other words, off to the side, I'm just going to consider what is x cubed divided by x? So this is one of those little tips. This is what we're doing. What is x cubed divided by x? I thought I heard somebody just say it. X squared. So I'm going to write it above the x squared term. That's to keep things organized, but do it. Okay, don't be lazy here and not do it. It'll make it easier for me to read as well, but it'll also make it easier for you if there's ever a tricky question. So we're going to write it over the x squared term. If you forget to do that and you get the right answer anyway, then it's fine, but try to get in the habit of doing that. But some people say, I don't understand that idea of how many times does x go into x cubed? But remember, you're essentially just doing that. X cubed divided by x. Okay? Then I multiply x squared times x, which gives me x cubed. And if you actually do that multiplication and you did everything correct, these two should be the same. Like they have to be the same for this process to work. If they're not the same, it's going to fall apart. You've done something wrong and the next step's not going to work. Okay? So when I multiply this by this, these have to be the same. And we're going to do this step. In this process, you iterate this step. You do the same step over and over and over again until you're done. And every time you go through that step, same thing. Those two first coefficients have to be the same. But then I'm going to do x squared times 3, and I get plus 3x squared. Okay? What do you think I do now? Subtract. Very good. Just like the long division we learned ages ago. So x cubed minus x cubed, well, I hope we all know that that's 0. You don't have to write 0, but that's 0. And again, that's the whole point of this process, that that's got to be 0. If at any step along the way that doesn't work out, you've made a mistake, and you got to go back and fix it. Find your mistake and fix it. It's got to work out that way. 4x squared minus 3x squared is x squared. So we're done the first run through. Now it all starts again, and we do it again. And we keep going until we've gone through every one of the terms and we have our answer, basically. Okay? Just like that other example that we saw, we do bring this down because we're going to need that. And start again. If you want to watch, you can just watch. X, how does x go into x squared? So again, just like we did over here, that means like x squared divided by x. What do you get? You get x. And it has to work out that way so that x times x gives me back x squared. So when I subtract those, I get 0. Like those are the, if you're getting confused, you're not sure how this all works out, that's the thinking that's involved. You think about this little trick up here, and you think about how whatever you come up with here, when I multiply it by whatever's here, because it's not always just going to be x, like it'll get a little bit more complicated, has to give me this term, so when I subtract I get 0, right? So it's almost like back in grade 9 when you're doing common factoring and you're kind of thinking about it backwards, like what do I put here so that when I multiply I get this? Does that make sense? And then x times 3 is 3x. And I subtract. 6x minus 3x is 3x. And I bring down the 5. You also don't have to write those arrows. That's just, I'm showing so people can see where things come from for the lesson. And we do the whole process over again. So go ahead and try it if you want, if you think you can do it. This one already is a little bit trickier because of the coefficient x. So 3x divided by x. How does x go into 3x? What do you think, Jason? It's 3. And if that's something that you're like, nah, I didn't know that, I don't know how, where does that come from, 3 times x gives me 3x. So what number do I want to put here so when I multiply it by this, I get this? And then 3 times 3 is 9. 5 minus 9 is negative 4. And we are done. I know I'm done because I got to the end of the line up here. Any questions about that? See how it's a very straightforward process with rules. Step 1, step 2, step 3, repeat. Step 1, step 2, step 3, repeat. Or step 4, however many steps you want to call it. Now we're going to write our division statement, our summary statement. Okay, so therefore, we don't rewrite the whole function. We just say f at x. I'm going to, and I wouldn't usually write this, but I'm just going to write it to remind us. Equals d at x times q at x plus r at x. What was d at x? That's the divisor. That was x plus 3. Make sure you put it in brackets. What's the quotient? That's that thing at the top, x squared plus x plus 3. And my remainder was negative 4, so just minus 4. Any questions about that? Can anybody describe the relationship between our result here and the original question that we were asked, like this statement right here? What's the relationship? How could you describe it? How could you help somebody else think about it and understand it?
Are they equivalent?
They are equivalent. What does that mean? And it's kind of a trivial thing to say, but that was the answer I was looking for, so that's perfect. I mean, it says right here, f at x equals, so they got to be equal, but like, what does that mean? See ya. Did you hear that? Very, very important. If you were to expand this, we all know how to expand this. Multiply this by this, and then subtract the 4. You should get back that. If you don't, you've made a mistake. So there's a check. An easy check that what you've done is correct. If I were to if I had time on a quiz and I wanted to actually, or a test or whatever, and I wanted to actually expand and do it, I would do it on like rough paper or off the side or on the back or something like that. You know, try not to muck it up in your question just because it can take it in there. Any questions? Everybody good? Okay, let's try another one. Woo, woo. Oh dear. Oh. Apparently if I flick it works. I bet if I use the mouse it'll work better. There we go. Oh geez. Okay. I really hope that gets fixed when I reboot. Because if it doesn't, I'm going to be in trouble. All right, so next one. This one's a little bit different. Like same process, but it's got a little twist to it, a little trick. And I want you to think about this trick and how, like, because it pops up in one way here, but it can pop up in other ways in other places. But the way we handle it is the same. You'll understand what I mean in a minute when we actually go through it. So keep in mind how we handle this. Does anybody see anything that jumps out at them or stands out that's sort of different from the last question, or that just you notice that maybe is kind of interesting? Ooh, very nice. Oh, those are for me? Oh, wonderful. Thank you. There's no x squared term. Very good. I thought maybe people would say, I think the last one was a cubed. I thought people would say, oh, this one's degree 4. That's going to be the same thing. You're just going to have to go through it more times, right? But it's the same idea. But exactly right. There's no x squared term. Is that going to be a problem? Absolutely, if we don't take it into account. Okay, so I'll show you how to take it into account. It would be very similar to if you were dividing into 1054, the 0 in the hundreds place. But because we write numbers like that with zeros, when you did that back in grade 4, it didn't matter because the 0 was already there. But in algebra, when we have a 0, we don't write that term. If there was some notation for writing the number 1024 without the 0, then it would be a problem, right? But it's not a problem with numbers, but it is a problem with algebra. So we're going to, I think that one was my fault. X minus 2 bracket. Here's what we're going to do. 2x to the 4th plus 5x cubed. We're going to add in what sometimes they call a ghost term. It's appropriate, I guess, for GALT. Or sometimes they call it like a placeholder. Okay, so plus 0x squared minus 7x plus 10. Yes, you have to do it for the process to work. If you forgot to do this, once you got to that point, all of a sudden you'd be like, what just happened here? Like, you'd get stuck and things would seem really strange. And hopefully that would be enough to click you into, oh, I forgot the ghost term. If there isn't any term missing. If this was like 2x to the 4th plus 10, you'd have to put those ghost terms in for each term that's missing. In between the first and the last, right? All the way to the constant. You'd have to put them in for each of those. Yes, absolutely. Okay. And sometimes you're going quickly and you miss it. I mean, even I miss them sometimes or whatever, right? Like it just happens. So not a big deal, but recognizing that that's what's happened is the important part. And trust me, it's like, if you're good at this and then all of a sudden something happens and one's not working, you're like, what just happened here? Probably you missed that placeholder term. Okay. It's a very, like you're doing everything right, but somehow it's not working out. That's what happens. Okay. So you can go ahead and start this one if you want. Try to get ahead of us. But I'll help you at least with this first step, since it's only the second one we've ever done. So what we're doing here is we're saying like x goes into 2x to the 4th. You have to ask yourself, what do I need to put up here to make it all work out? And remember the little tricks. You could think of it as this divided by this, or you could think, what do I have to multiply in order to get? So how many people think they know what it is? John's the only one with his hand up. Go for it. 2x cubed. I like it. So I'm going to give you a minute to try, see if you can figure it out. It's the same step every time. So, in one question, you're practicing it like 3 or 4 times. You get good at it quickly, and it's pretty straightforward. It's literally going to be like 4 or 5 minus -4, but it changes your math. It's 5 minus -4. See, and again, it's funny. Like, there's all these little like hiccups along the way that you got to think of. If you go through this quickly, you can make little mistakes. Okay, so let's do this. 2x cubed times x is 2x to the fourth. 2x cubed times negative 2, right? So you're multiplying. Now I'm multiplying it by this. And I get negative 4x cubed. And everything's lined up. I've got x cubed over x cubed, x to the fourth over x to the fourth. So that's all good. I'm going to subtract. And right here is enough that, like, back to grade 7, 8, 9, when we started integer math, what's 5 minus negative 4? Like, because we're thinking about bigger, harder things, sometimes we mess up on the little easy things. So slow yourself down and force yourself to, like, say it in your head that way or whatever it is. Do it on your calculator. What does that work out to? Thank you. 9. Positive 9x cubed. Bring down the 0x squared. And start the process over again. I know a lot of you are ahead of me, so I'm just going to keep going, and you can check your answers as we go. Oh, dear. Some people get in the habit of just writing the same thing without actually multiplying, but that's a little check that what you're doing is correct. When I do this times this to make sure that those two are the same, I would encourage you to actually take the time to think about it. So again, negative 7 minus negative 36. Like, you just got to be careful. So that should work out to 29x. Bring down the 10. Oops. And I'm done. Try to write your division statement, your summary statement. Remember, it's d at x, which was x minus 2, and these parts have to be in brackets because you're multiplying the whole thing by the whole thing. So this is 2x cubed plus 9x squared plus 18x plus 29, bracket, plus 68. d at x times q at x plus r at x. Divisor times the quotient plus the remainder, equal to the dividend, what we call the dividend. Any questions? We're going to do one more example. But that's basically, that is the process. 10 minus negative 58 would be 10 plus 58. I think it's positive. You can check it on your calculator. Okay, one more. This one is, again, is slightly different, but we do it the same way. There's not really anything you have to take into account, so I want you to try starting it. on your own. But we will do it together. Think about, like, go with your gut. What's your intuition tell you should do since this one is slightly different? Okay, very good. A lot of people are on the right track. I'm just going to finish handing these out, and then we're going to take up that first step. So this is a good moment because you probably noticed. Sure, you noticed that this one's a little bit different, and you had to do like a gut check. Well, it's different, so what does my gut tell me I do in this case? Like, there's a couple of little things that you would have to do. And now you get to find out if your gut was right or if your gut was wrong. If your gut was right, good. Keep that in mind. Practice a little bit, you're probably good. If your gut was wrong, be really aware of that and just keep that in the back of your mind that it wasn't what you expected. And then if you ever find yourself in a place where you're not sure what to do and you're trying to go on your gut, you can really think about, oh, last time I did this, it wasn't actually right. So how can I figure out what the right thing should be? So let me get this written down. There's no ghost terms or placeholder terms or anything like that, so we're good. So what was the trick? The trick is that our divisor has 3 terms in it. But you start the same, x squared into x to the 4th. What does that give me? X squared. And just like I said, you can use that rule to put it over the x squared term. That's what I would do, absolutely, 100%. So some people, I think, weren't sure where to put it. But yes, that's where you would put it. X squared times x squared is x to the 4th. Now, and then we multiply it by every term. This is the other thing that's maybe a little bit different and people could have been unsure of. So x squared times 2x is plus 2x cubed, and x squared times 3 is plus 3x squared. And then I subtract them all. X to the 4th minus x to the 4th, 0, good. Negative 2x cubed minus 2x cubed should be negative 4x cubed. 6x squared minus 3x squared is 3x squared. I bring down the 2x and I repeat. And notice how I have 3 terms here and I have 3 terms here. Like, that's not by accident. It's going to work out that way. It's going to happen that way every time as we proceed through the rest of the question. Okay, so what does this do? This goes in negative 4x times. So negative 4x times x squared gives me negative 4x cubed. That's good. That's minus 8x squared. And that's minus 12x. So subtract, I get 0. This is 11x squared. And this is plus 14x. Bring down the 1. And if this is clicking with you, you probably notice we have to do it one more time, then we're going to be done. X squared goes into 11x 11 times, so plus 11. So that when I multiply, I get the same thing there. That has to happen. 11 times 2x is 22x. And 11 times 3 is 33. And when I subtract, I get 0. I get 14 minus 22 is negative 8x. And 1 minus 33 is negative 32. How many people had that right, or more or less right along the way? Like, you don't actually have to put your hand up if you don't want, but like generally, even though it was a bit different, you were on the right track. It's good. Therefore, I think just watch for a minute because I want you to see something that happens here. Therefore, f at x equals, so the divisor x squared plus 2x plus 3 times the quotient, which is x squared minus 4x plus 11, plus the remainder, which is minus 8x minus 32. Like, you could put plus the remainder in brackets if you want, or you could just write it as terms like that, same idea. Now, what could I look for, aside from just expanding the entire thing? What could I look for that would give me a sense of, especially one that's a little bit different like this, that I'm on the right track? It might not be obvious to you now, but when you do these kinds on your own that are a little bit different, this is a good tip. Huh?
Seems like your response goes over your degree.
Very nice. Good intuition. So notice how my first terms here, x squared times x squared, is going to give me x to the 4th. That's going to work out. The other thing I could do very quickly is my only constant is going to come from here. 3 times 11, which is 33, minus 32 gives me 1. So there's another quick check that my first term and my last term are correct when I expand. If that's the case, probably the rest are going to work out as well. Not necessarily, though. So you could expand the whole thing, but just looking at the degree, is this a polynomial of degree 4? It is. So that's a good start. That means I didn't get tripped up with the fact that this was a trinomial, that kind of thing. Something good to think about just in general is degree. Last thing I want to say is we're going to do a different type tomorrow. But what you need to know is, for questions like this, where it's a trinomial out front, tomorrow's method won't work. Okay? So if I have a different question like this, I have to use long division. The method we will learn tomorrow only works for one specific case. Luckily, it's the case we do most often in this course, moving on past tomorrow. But in general, if I was dividing a trinomial, I would have to do long division. Okay. As we practice, that'll probably be easier to remember. Any questions? So the worksheet that you're doing, you only have to do questions 1, 2, 3. You'll notice question number 4 asks you to do something else that we haven't learned yet. Any questions about any of this? Questions. How many you came for?
Long division, yeah.
Long division. They did very well, actually. This last one, we did like a trinomial. Right? Cool. They, without me showing them, they were doing it kind of on their own. Like, we're guessing at what to do, figuring out what to do. It's a little bit trickier, right? Yeah. Like lining up the terms and what, and like, you gotta multiply by 3. Yeah, see, I do this too. Yeah, totally. Some kids, but I find you usually for the ones who have a lot right here, and they don't need to. But I still told them, please do it because it does help.
That's cool. How, like, are you just writing with the stylus on it?
Yeah,
So then all you notes are,
yeah.
that's pretty cool.
It is pretty slow. And I can flip back and forth what draft and stuff. But Windows was updated recently, so I updated it over the weekend. And then like the touchscreen wasn't working properly, so it was like